Alright, so welcome back to map projections, and now we are in the topic 1 of this course, which is the introduction to map projections. So this is for the authors and contributors and for the copyright notice. So I guess kabalo naman mo ana sa ato ang orientation. And this will be the outline of the presentation. There are 6 parts. Part 1 will be the general concepts. Part 2 is the coordinate and coordinate system. Part 3, review on datums and ellipsoids. Part 4, levels of map classification. Part 5 is scale variation and angular distortion. Part 6 is the classification or selection of map projection. And this will be the intended learning outcomes. After this lecture and exercises, you, the student, must have identified and discussed the general concepts of map projections, coordinates and coordinate systems, and datums. Next is the identified and discussed the various datums used for map projections, discuss the map projection process, identified and discussed the characteristic of map projections. Next is the identified and discussed the limitations and impacts of map projections such as scale variations and angular distortions, identified and discussed the importance of map projections in genetic engineering, identified and discussed the classification of map projections and criteria for selection and usage. Alright, so let's start. The part 1 will be the general concepts. So alright, before we are going to discuss the proper discussion on the map projections, general concepts, let's take first the differences between globe and map. A globe is a three-dimensional. We all know that guys because round man ang globe. And in globe, it is expensive, cumbersome, and no details. Pero si globe has no distortion. Wala siya distortion kung unsay naa diha nga size, unsay naa diha ang area sa isa ka lugar. So mao jud na siya in reality. And for map, so si map is two-dimensional and easier to measure distances and area and direction kay since magamit lang ka ruler, then i-determine kung pilay distance, area, and direction. And in a map, it can show more detail compared to globe. Easy to work with, portable, and cheaper. But the disadvantage is na siya distortion. So kung say makita nimo diha sa map, magdepende na siya kung unsa nga projection ang gigamit ana. Kung di conserve ba niya ang shape, di conserve ba niya ang size and direction, etc. So globe are accurate but expensive. So malakong giga ganina no. A person looking at a globe sees a perspective of view. Like for example, the view from a single point. And a person looking at a map sees the orthographic view. The view is directly overhead for all the points. So itawag na siya orthographic view kaya it's because from the infinite man ang imuhang direction. Like for example, tanaw ka karon ani nga globe. So ang imong pananaw is nasa infinite, no? So from the sa tayo na adre imong eyes, no, nakita niya is kanara nga perspective. Kanara niya ang perspective. And disadvantages of disadvantages of globe is expensive and difficult to make. Since yun lang baka magbuhat around na shape, cover pa nimo and so on. It's cumbersome and awkward to store or transport. Bilang magbitbit ka, like for example, maadto ka isa ka lugar, magdala ka og globe, di ba? So awkward siya compared to map na handy lang siya. And large globe need to show a small area in great detail. And globe is an undevelopable surface. It cannot be flattened into a sheet of paper without distortion of area, distance, shape, and direction. So kung imuha na siyang i-convert into two-dimensional, naagid na siya distortion. And for the flat maps, so it overcome many of the shortcomings for globe. Various projections have been devised to project globe into a flat surface, and the surface of the earth tears when you peel and flatten it. Peel a globe and you will get globe pores. So, yung kitahay na kay globe, tapos himuonin mo siyang imo na siyang panitan or abrihan or i-peel nimo siya using sa kaning mga grids. So ingani ang mahitabo niya, globe bore. Globe bore ang tawag na niya. So na distortion kay for example diri nga area wala man ni. So kinahanglan nimo siya ito dimensional, so naay distortion. And in flat maps, all projections distort, no? Distort, each projection distorts differently. So tanan nga klase sa projections na distortion. And katong nga mga projection mo distort na siya in a different way, unique siya. Remember that maps are models, generalized representations or reality. But it does not depict the reality kay for example kanang naman yun siya distortion, so magdepende na lang kung unsa imong i-preserve pag project. The larger the land surface represented in the Earth's curvature or represented in the more curvature in the Earth encompassed, and the greater the necessity for projection to construct flat maps. So this is the example of a map, no, showing a two-dimensional map, and it is a 100-year rain return of flood hazard map of Cabadbaran City. So makita ninyo diri ana na siya gibutang nga projection kung unsa yung projection na iyang gigamit. Sa scale bar tapos di na makita na siya gagmay kay ang text. So na projection diyan iyang gigamit to arrive this kind of map. To start the discussion about map projection, let us recall that is the meaning of a map. So a map is from the Latin word mappa, means napkin or cloth. No? So a map is a representation usually on a flat surface as of the features of an area of the earth or portion of the heavens, showing them in a respective form, sizes, and relationships according to some convention of representation. Another definition is a map is a plan, outline diagram, map, a chart, graph, that is referred to a representation of surfaces, areas, or facts. So, masabtan naman na siya. The maps are an important tool for understanding and navigating the world around us. Okay, magbitbit ka kung nato ka sa isa ka place, magbitbit ka mapa para ma-familiar ka atong lugar. And let us recall the different kinds of maps. We have physical maps. So physical maps shows what the land itself looks alike, identify the physical features. So from the word itself, physical. And we have also distribution maps. It shows where something can be found. Next is political maps. It shows us how an area is divided into countries, states, provinces, and other units. So political boundaries. For example, for Butuan City, Cabadbaran City, and so on. And we have also movement maps. It shows us how to get around, such as road maps. So here is the example of physical map. Kung say forma sa yuta, mao na ipakita sa physical map. For example, contour map for elevation, and we have also topographical, ilang nanay hill shade, and this one sa slope ata ni, if I'm not mistaken. Next is distribution map. So here is an example of a distribution map that shows the distribution of rhinos in Africa. So distribution map is shows us where we can found something. For example, sa rhinos, kanang red nga part, yan ay mo makita ang mga rhinos. So that's a distribution map. Next is a political map. Political map, for example, is the political map of India. So kanitanan nga nakita nimo diri is India. India na siya. So that's a political boundary of India. So on as the Philippines, nakita na siguro mo sa Philippines. Next is movement map. Movement map, for example, kani siya is mga this one are roads sa kaninga place. So route map is nakakadulong diri kung tayo nakadiri ang part kung saan mo pagka balong maabot ka diri diri nga part. So for example, dili ka moagi. So that's movement. And let's define what is map projection. So map projection is a systematic rendering of locations from curved earth surface into a flat map. Like kani, na globe or na the three-dimensional earth. So iagi siya o map projection process like cylindrical. Kaning imagine na ninyo nga amoy paper nga tuyok or wrap aning sa globe, no? So tayo isulod mo na siya kaning globe, isulod mo diha. So pag project ana niya mahimo siyang ani na atong tawag na two-dimensional, no? And kani pod, no, for example, imagine nga nagbuhat kang cone nga paper, itaklob nimo diha sa globe. So yan ay pod ang iyang forma. Or kung imuha ning ision or yung mo siyang panita, yung mo na siyang ablihan, yung mo na siyang two-dimensional, pwede siya na yan. And in map projection, distortions are unavoidable. So niligid na nato siya malikayan. Some areas will be compressed and others will be stretched. Adjud na siya map projection. Okay? Na-adjud siya may tabo nga distortion. Okay? It's because three-dimensional, hindi mo two-dimensional. So hindi lang yan nakadali map project. So another definition of map projection is a systematic representation of all or part of the surface of a round body, especially the earth on a plane. So same na gyapon, no, na atay earth diri ano, ilang pag-project niya. So example of this projection is naka sa imagine na to nga naay globe, no, and sa center ato nga globe is naay light. Then pagpasigaon to na to nga light, so i-wrap na to siyang round body as a or cylinder, no, cylindrical projection siya. So pasigaon to siya, mo-reflect ang katong rays padulong sa two-dimensional body. So ano nang nadantay cylindrical projection. So another this representation is another type of projection, no, which we call second, no, second siya nga types of projection. Okay? It's because kaduha siya ni touch kung mo ni ang earth, no, mo ni ang round body which is ang globe. So ikaduha siya nag-touch, okay, 1 and 2. And from this map surface, no, so as you can see na si distance AB daw, distance A to B is less than the A to B in the curved na part. And si distance DE is greater than the curved distance of DE na sa sulod. So pasabot kung naa sa sulod ang map surface, so mas less siya kung distance compared kung naa siya sa gawas. So second siya kay kaduha siya nag-touch sa surface. So map projections can be conceptually created by projecting one geometric shape, which is a sphere, into another like a cone, cylinder, or plane. And in cylindrical, so it projects a sphere into another, which is a cylinder, from the word itself. And conic, it projects a sphere into a cone, and a planar, which projects a sphere into a plane. And most of the projections are based on a developable surface like cones, cylinder, and planes. So ato nang i-discuss sa ganina. And some projections are not based on developable surfaces like a direct mathematical projection, such as example ani nila is ang pseudo-cylindrical, molywide, Goody homolocene or homolocine are the examples, no? And as per the types of projection, we have three types. First is a conic type of projection. Example of these are the Albers equal area, Lambert conformal, and these are good for east to west land areas. And for cylindrical, we have sample here, the transverse Mercator, and this is good for the north to south land areas. And last type is the azimuthal. Example of this one is the Lambert azimuthal equal area, which is good for global views. So these are, muna kong i-discuss ngayon itong mga developable surfaces or areas. For example, if ang imuhang projection method or type is cylindrical, so imo siyang i-cut into a line, so ngayon na siya og two-dimensional. So this two-dimensional area is the developable surface. So as the conic, so na siya cone. So pag i-cut nimo na dalong dito, so kani nga surface ang developable. And example for cylindrical projections, we have different aspects, which is the normal, transverse, and oblique. And cylindrical projection are good for displaying the work. Another example for cylindrical, we have transverse Mercator. So pag normal ang iyang aspect is sulod lang nimo siya ang globe, tapos i-wrap lang nimo siya og i-wrap lang nimo siya ang katong globe. Then pag imo na siyang i-cut, that's the cylindrical projection. Normal. So ang iyahang ang equator, which is mao ang naka-touch dito sa side sa cylinder, nasa cylinder. And this type of projection is tangent. Okay, isa lang ang nag-touch. Another one is normal. Another one for normal, is this one. Kaduha siya nag-touch. Diri nga part, diri nga part. So second ang tawag ana ni second. And we have also another aspect which is this transverse. So ang nag-touch na po diri niya sa part sa cylinder is ang meridian. Meridian na north to south. And oblique, takilid siya. Okay, the word itself, oblique. So isa lagi ako nang nag-touch pero across na siya sa meridian of parallels. That's it. For conic, so ingani ang forma pag tangent, kasalang, isa lang siya. Na siya meridian, parallel na nag touch sa cone. And ang katong cutting line na akong giingon before is ang central meridian. So for the parallels, pag second pod, duha ka parallels ang duha ka parallels ang ni-touch sa cone. And conic projection usually is good for displaying mid-latitude area such as United States. So for conic, tangent, na siya standard parallel. Ang tawag sa katong parallel nga nag-touch kumbaga sa conic is moto siya ang standard parallel. And ang katong cutting line which is ang central meridian. So pag i-cut na to na siya, ay ganin ang may forma. Pag second pod, so kaduha siya nag-touch, so duha ka buki ang standard parallel, niya yung central meridian is katong cutting line. Pag i-cut mo na siya, ay ganin ang may duha na ka standard parallel, isa ka central meridian. For planar projection, this is good for displaying hemisphere into one focus. And dapat siya three aspects. Polar aspect is ang plane, ibutang siya sa pole. And pag equatorial, ang plane pole is ibutang sa equator. And oblique is anywhere basta kay dili siya equatorial, dili po siya polar. Basta oblique siya, from the word itself, oblique, takilid or sa kilid. Example of the azimuthal is the Lambert azimuthal equal area. Ano siya ang another perspective, polar, equatorial, and oblique. And there are different polar aspect in different perspective. So natagitawag na mnemonic na perspective in projecting azimuthal. So pag mnemonic, no? So naadri ang plane, ang source ay yahang projection is naa sa center, no? Center sa Earth, center sa globe pala, center sa globe. So yun ang i-project na siya source of projection here, for example a light or isa ba. So i-project na siya isa-isa hangtod sa makabuo siyang inani. And for stereographic, ang iyang source of projection is from the other side. Kung mao ni ang imong plane sa polar, other side siya na adiri ang source of projection. I-project na siya again isa-isa, nga niya ang may forma. And for orthographic na perspective, the source of projection is from infinite. No? For example, nasa layo. Lahi-lahi sila grace, kumbaga. No? So, pag nasa layo, ang orthographic, ano ang pagpalog. And we have these projection properties. We have four projection properties. We have conformality or form. The shape is preserved locally on conformal maps. So, in this projection properties, ang shape ang iyang preserve. Shape. So, muna kong gaingon ka ganina na any projection is dapat na siya i-preserve. For conformality nga property, ang shape ang iyang i-preserve. For distance, no, from the word itself, ang distance po. So, a map is equidistant when it portrays distances from the center of the projection to any other place on the map. Kaya kung i-preserve anis ang distance. For direction, so a map preserves direction when azimuth or angles from a point on a line to another point are portrayed correctly in all directions. So, ang iyang i-preserve anis ang direction. And for area, when a map portrays areas over the entire map, so that all map areas have been same proportional relationship to the areas on the earth that they represent, the map is an equal area map. Again, from the word itself, area ang iyang represent. Alright, so here is the example of some projection that distort areas. Example is the Mercator projection. As you can see, tanaw na to nga dili jud siya mao ang dagway no sa isa ka area. For example, kani this is the another projection and kani po this another projection. Maglahi-lahi jud siya no, dili ma-distort ang iyahang area. Kaya matawa mas gamay ni kaning compared ding Africa no, sa Africa mas gamay siya compared diri and diri pod na part sa ilalom mas dako no? I-compare din mo sa Picas. So ma-distort jud ang iyahang area. Another is example for forms. Some azimuthal that distort the form of the feature. So example is the azimuthal equidistant. Kani is conformal conic. Kani is equidistant. So lahi siya og forma, lahi siya output. So ang form is conformal, mo ni ang forma jud na kung i-preserve nimo ang forma. Pero pag ang kani i-preserve niya ang distance, so lahi siyang forma na awang. Ang Africa compared din mo diri lahi siyang form no, kaya ang yamang i-preserve anis ang distance. And another projection properties no, makita niyo mo nga nag distort ang isa ka lugar no? So kani is stereographic na type sa azimuthal no? Or sa planar. And pag-abot di sa area conic, ang iyang gi-preserve is ang area, so ingani na yung forma. And in Mercator, ingani ang forma sa isa ka lugar. Pag azimuthal po, ingani azimuthal equidistant, diba lahi ra kaayo. And for Lambert conformal, same gyapon na place, ingani ang forma, pero pag-abot sa cylindrical, ingani ang forma. So again, different projection properties ang gina-preserve no, sa projection. So for distance, there are many projections that distort distances. Example of this one is the equirectangular projection. So here from the illustration, so Madison to Madrid, naa siya'y in reality or in the globe, naa siya'y 6.78 kilometers. No? While the Madison to Buenos Aires pala. So, naa siya'y 9.18 kilometers. But on the map, no, labi na sa equirectangular projection, same na lang sila o distance. So, na-distort na siya. Na-distort siya. And for the azimuthal equidistant, tanawin mo na another projection na po siya nga mag-distort ang distance. From Madison to Madrid again, ano siya yung lines on the in reality same ra gihapon. 6.78 kilometers sa Madison to Buenos Aires, no, is 9.18 kilometers. But on the lines on the map of the azimuthal equidistant projection is naa na siya ratio nga 1.35. Dili pareha sa katong equirectangular na projection kaganina, same jud siya, yung ratio is 1. And here are some important note na the properties of areas, distance, and form are mutually exclusive. If you have a map projection that preserves one, it will not distort to other two. So kumbaga, isa-isa lang, no? Isa-isa lang siya. Kung unsay imong gusto i-preserve, magpili lang ka kung unsay may preserve, ang distance ba, ang area, or ang form. Dili pwede magsabay ang duha. Walay projection nga magsabay ang preservation sa duha ka properties. Another projection properties is the direction, the preservation of the direction. And sometimes as a straight line is not the shortest path, no? Pag tunato ang kanang shortest path between those 2 points on the globe is the shortest, but dili day siya. We call this curved shortest distance path as the great circle, no? Great circle routes, or kanang gitawag na geodesic, no? Geodesic line, no? Kumbaga nga kung kanisi, kung from New York to this other point, no, sa earth or sa map, no, kung ang kaning shortest distance dili mao ang pinaka shortest na path. Pag to na to nga siya ang kung straight, so siya ang pinaka shortest path, dili di ay siya. So ang pinaka shortest na distance is ang kaning curve, no, ang kaning curve kaning ni sabay sa great circle. And ang kaning line is what we call geodesic, or ang kanang gitawag na great circle routes. And on the other hand, a path like a straight line where you keep yourself pointed on the exact same compass direction the whole time is called rhamblines or loxodrome. Tawagan na niya loxodrome. Kaning straight line, loxodrome or rhamblines. And to sum up, no, si area, the preservation of area is the correct earth surface area. Example ani niya are Albers equal area. This is important for mass balances and for preservation of shape, that local angles are shown correctly kung gusto nimong ipakita, no, ang correct na local angles. And for direction, if you want all directions are shown correctly relative to the center, example ani niya is ang Lambert azimuthal equal area. And for distance, if you want to preserve along particular lines. So there are also some projections that preserves two properties, pero malimit lang din siya. Usually isa ka properties lang gid ang imong pilihan. Alright, so let's go now to the part 2 of this topic, which is the coordinate and coordinate systems. Before we're going to discuss the coordinate and coordinate system, we need to learn some knowledge about latitude and longitude. Where how do we find places on maps? Siyempre, kung nalang kay latitude and longitude, you can locate now the different places in the Earth. When you say latitude, it is a line of the lines of latitude is runs horizontally. Horizontal siya. Horizontal kani. Ano siya mga lines of latitude padulong sa taas. And latitude is measured in degrees, And the equator is the 0 degrees latitude. And the lines of latitude locates the places north or south of the equator. And the North Pole is 90 degrees north latitude, and the South Pole is the 90 degrees south latitude. So, 90 is 90 north, 90 north, 90 south. So, dili dapat mo lapas ang latitude og 90. So, 90 north or south na siya. And when we say longitude, no, so, it is run vertically. Paana po siya from north down to south. Mo na siya ang longitude. And they are also called as meridians. And the prime meridian is found in the Greenwich, England. So, ang pamintag prime meridian, 0 longitude. And the prime meridian is 0 degrees longitude. And the lines of longitude locate places east or west on the prime meridian. And there are 180 degrees of east longitude and 180 degrees of west longitude. Alright, so speaking of parallels and meridians, we need to understand these terms. No? Pag tag degrees, it is the units of latitude and longitude. And ang iyang symbol is kani. Symbol sa degrees. And for equator, it is an imaginary line that runs around the center of the Earth, halfway between the North and the South poles. So equator is 0 degrees latitude. And for meridians, this is lines of longitude. No? These are imaginary lines on Earth that run between the North and South poles. And we have also another term, the North Pole is the point on the Earth located at 90 degrees north latitude, where the lines of longitudes are met. So 90 degrees 90 degrees north na latitude is ang North Pole. And parallels, or what we call lines of latitude, are the imaginary lines on the Earth that run parallel to the equator. So parallels po are the lines of latitude na pakunggiing di ganina. And for prime meridian is the imaginary line that runs from North Pole to the South Pole of the Earth at 0 degrees longitude. So, prime meridian, 0 degrees longitude, located din siya at Greenwich, England. And South Pole is the point on the Earth located at 90 degrees south latitude, where the lines of longitude met. 90 degrees south is South Pole. A globe is more accurate the way to show the Earth since the globe is spherical. So, mga ganito akong discuss. The North Pole is at very top of the Earth and the South Pole is the very bottom. So, simple lang kayo nga mga term, definitional term. And the North and South Poles are the farthest north and south points in the globe. May point naman lang siya, so 90 degrees north and 90 degrees south. So, those are poles. So here are some notes, no, on the parallels and meridians. No, si parallels daw, or the line of latitude is run east to west. Run east to west around the globe. And they are run east to west kay paana man siya. So paana siya. Dirigikan paana dito. So east to west. They are parallel because they never touch. Of course. From the mathematical term parallel, dito siya pwede mag-intersect. Latitude lines are used to measure distances north or south of the equator. So, wala kong i-discuss ganina. Distances are measured in degrees. And equator is the middle, which is the 0 degrees latitude. North Pole is the farthest point. Yun yung ganina. And South Pole is the farthest point of the south. And all other parallels are between 0 degrees to 90 degrees. Wala na yung mula pa sa 90 pa. And 4 meridians are run into the north-south direction. North to south direction. So, wala siya ang meridians. Meet at the North and South Pole. The prime meridian is in Greenwich, England. And the meridian measure distance from east to west of the prime meridian. So, east longitude extend in the east of the prime meridian, and west pod is extended in the west from prime meridian. Alright, so let's move on to the spatial reference system. So why we need to know about this spatial reference system? So it is because that we are now in the modern cartographers na kumbaga. So we mapped geographical information using the GIS. So out from that, we need to know what is the reference system. So na yung spatial reference system, guys, because the GIS, ang iyan pong gina-work out is ang spatial data. That data needs to be placed at a location. So is i-georeference nimo siya. And globes are great for visualization but not practical for many uses, guys, because moto ka sa mga places, no, gusto mo dadala ka globe para lang makaabot ka sa isa ka specific nga lugar or to guide you, di ba? So mas handy man kung mapa, no? So around the earth does not fit without a distortion on a flat piece of paper. So from the earth models, i-downscaled siya into globe from gamay, then from globe mo siyang two-dimensional, which is ang mapa. And spatial reference systems are the key component of writing spatial applications, and it helps describe where features are located in the real world. Siyempre na naman siya coordinate systems, na naman siya system na naka-georef na siya. And different spatial reference systems are used for different purposes. And the term coordinate reference system has the same meaning as a spatial reference system. And that terms are used interchangeably. So, pwede siya magkabaylo-baylo sa spatial reference system or sa coordinate reference system. And most references or coordinate systems fall into the two categories, which is ang geographic o ang projected. So, muna ni karon ang tawag na ito nga coordinate systems. So, pag may tag-spatial reference, dapat na akay datum. Datum is ang origin point nimo sa isa ka specific na lugar. Projection, kung unsa ang gigamit nimo from 3-dimensional para himuon nimo siyang 2-dimensional. And we need to have also the coordinate system. So, unsa gigamit na coordinate system, it's either geographic ba siya or projected. So now let's differentiate between geographic coordinate system and projected coordinate system. So when we say geographic coordinate system, the references of the location on the earth with spherical coordinates. Pag makita kang coordinate system na naka latitude and longitude siya, so mo na siya ang geographic, and has a datum, angular unit of measure, and a central meridian. Of course, namagin siya dapat basihan sa pag-project niya. And for projected coordinate system, Cartesian na ang coordinates. Anong gitawag na ito? Northings and eastings. So, for example, in this one, distances must have units. Like, for example, kani, so 5 meters and 4 meters ang iyang coordinates. And latitude ang iyang origin, and napod siya central meridian. So, that's for projected coordinate system. And when we say geographic coordinate system, it uses a 3-dimensional ellipsoid surface to define locations on the earth. So, as we all know, no, sa atong geometric geodesy, na pag mo top ganitag horizontal na coordinate system, so we will use the ellipsoidal shape. And there are 3 parts to geographic coordinate system. We have the datum, which is based on the ellipsoidal model of the earth, and napod tayo gitawag na prime meridian, which is the 0 degrees as a origin, and dapat na atay angular unit of measure. And the points referenced by latitude and longitude. So mao ni siya, kung diyan ka ganina pag geographic, kung makita ganin mo latitude and longitude, naka geographic coordinate system na siya. And for projected, it is based on the geographic coordinate system, again, based on the ellipsoids. And ang location niya is identified by X and Y coordinates. So, Cartesian siya nga pamagi. Is defined on a flat 2-dimensional surface and has a constant length of angles and areas across the two dimensions. So, basically, ang kalainan ng gitila pag geographic, attitude longitude, and for projected is naka-Cartesian siya. So I guess this ends for the part 1 and part 2 of this topic. See you for the next video. Keep safe and good day.